Hello everyone. Thank you for listening to us. Our team name is Runaround for today, Asimov's law to ethically resolve dilemmas in robotic assistance. So, talking about our team name, Runaround, it is a famous science fiction novel written by author Isaac Asimov, where he talked about the first law of robotics. Here in our approach, the fetch robot will follow three ground rules that will resembling to the Asimov's three laws, ensuring the highest well-being of human beings, listening to the commands of the residents, staffs, and visitors as long as it does not conflict with the first rule, and lastly, protecting itself from harm as long as it does not conflict with the first two rules. In the report, we addressed 11 dilemmas. Let's talk about some of them now. The very first dilemma is how to prioritize commands. To address this challenge, we have implemented a priority queue system. Here, the robot categorizes commands into separate queues for regular situations and red alert emergencies. For regular times, it prioritizes in this order: immediate threats, health risk, and general request. And during a red alert situation, the robot will give highest preference to the commands by the security guard to fetch fire extinguishers or weapons as needed. Only after that, he will follow the normal priority queue. In the next dilemma, what if residents command for something that is harmful to their health or objects that are dangerous? Such as the residents may command the fetch robot for keys of the medical area and may intake any wrong medicine. For these cases, the robot will have a database to store the information about the residents. In our report, we have provided two detailed chart about the information that should be included in its database. The next dilemma is about cultural sensitivity. In the elderly care home, to ensure the fetch robot avoids biases while fetching, it should be trained with a dataset from a wide range of cultures and demographics. When it comes to fetch robots, ensuring the safe retrieval of personal belongings while avoiding mix-ups is crucial. So we use the bottom-up approach where the robot will require explicit authorization from the resident for retrieving their personal items like wallet or medical records. So let's talk about our proposed robot design. Here, voice commands and gesture interpretation will provide a user-friendly interface for the residents who have limited mobility. We also included a biometric data adaptation method that allows the robot to personalize its responses based on individual needs. To ensure the privacy of the residents and respect HIPAA laws, the robot will only have the info of prohibited items for individuals rather than having any medical information. We choose to use advanced algorithm and technology to enable efficient movement, object recognition, and natural language processing. Also, the robot solves its dilemmas by fundamental rules and contextual analysis using face gesture recognition. By incorporating these design choices, the face robot ensures a safe and accessible environment for everyone in the elderly care home. The robot working procedure can be summarized as follows. It starts with receiving a command from the user and identify the speaker through voice recognition. If the speaker is unrecognized, the robot disregards the command. If the speaker is recognized, the robot checks the potential dangers of fetching it by risk calculation. Based on the evaluation, the robot determines whether to fetch the item, refrain from fetching it, or seek permission from the nurse. Our proposed design of the robot prioritizes safety and well-being while ensuring improved quality of life for residents. It does not breach privacy and makes the life of staffs and residents easier. Our design has some technical limitations too. It may not be able to identify emergent commands or detect emotions properly all the time. Based on our limitations, we have performed a risk analysis using a favor chart. Here we have evaluated the impact and likelihood of the event on the scale of 1 to 5, where 5 means highest and 1 means lowest. Limitations that are in the green box means the effect of that limitation is low. The yellow box means the limitations need to be further evaluated, and the red box means limitations have a high chance of causing high risk and need to be solved immediately. The chart shows us that our limitations are very unlikely to create hazardous situations, which makes our design suitable for the elderly care home. Thank you everyone for listening to us. Hope you find our presentation and report useful and interesting.